This video is an overview of developing Electron-based apps for the Safe network. In most cases, I recommend developing web-based applications, but there are cases where you may need file access, file system access, or to make system calls that are just not possible in a sandboxed browser environment. So we'll be using Node.js and Electron here. And please know that this is not a comprehensive tutorial. I want to go over pain points and high-level concepts. So getting right into it, make sure you have Git installed, make sure you have Node installed, and I suggest using a version manager. This, if you're on Linux, works very nicely. Windows does have its own Node version manager. It's fine. It doesn't work as nicely, but it's better than nothing. And as I said, I'm on Linux, so the only important thing you really need to know is to install this this bundle, Build Essential bundle, and this library, the gconf2 library, which Electron depends on. However, it's no longer shipped with Ubuntu as version 17. I'm not going to cover anything specific to Windows. If you Windows users are out there, please let me know if you need more coverage there. For the past 2 years, I've been working in a Windows developer environment, so I am familiar with it. I'm just not working with it anymore. Okay, the next part is getting your browser. You can go to the repository and get something that's already packaged for you. And for development, I recommend just dealing with these packages with the -dev postfix. They run against mock routing instead of connecting to the live network. Let me go back to that. Or I do recommend highly to learn how to package your own browser from source, build and package from source, cloning first. It's a good skill. Okay, so the browser, and then the next piece is getting our skeleton, our basic Electron application, which we will not be building from scratch. This is something nice put together for us. So, which I have here. All right. Examples. Make sure. Okay, then once you're in examples, then cd into safe app Electron quick start, and yeah, let's have you do this first. Install, I think. Yeah, I think that's the okay thing to do first. And then you can start it, and you'll see you have a basic application, which doesn't do anything. It doesn't connect to mock routing or anything. So the next thing we need to do is, what makes that possible to connect to the Safe network is this client library, which is listed on npm as @Maidsafe safe node app. And just to clarify what exactly that is, it is this safe app node.js repository. Yeah, so we want to install that. Now, one thing I want to cover here is this node_env environment variable, which you're being instructed to use to install the client library. The only thing that this does is lets the client library know that we want to download the core client libraries that interface with mock routing instead of connecting to the live network. That's the only purpose of node env equals dev. And just to give you a little bit more information, safe app node.js relies on, or depends on, safe client libs. Okay, and that's the core client library written primarily in Rust. Okay, so let's do that. And I want to show you, let's see, vi bash rc. Oh, wait, what did I do wrong there? Oops, tilde. Vi bash rc. In my dash config, I have node-env exported automatically when a new terminal is opened up. That way I don't have to set it every time I install my dependencies. So let's install safe-app node.js. Okay, and you'll see there it's downloading safe-app. Okay, and then the next piece is, so after you install, what is this? After you install the client library, the rest of the tutorial is about writing the code that actually, makes up operations of the safe network. We're not going to write the code in this tutorial. As I said, it's not comprehensive. So what we're going to do is, what it's having you do, the tutorial is having you fill out this skeleton, right? But there's also this file, safenetwork_code.js, which has an already completed file. So instead of relying on the skeleton, let's rely on safenetwork_code.js. Now, I'm going to run into a problem, and I'm thinking about how to properly, this is a pain point that I think is important. But I'm not quite sure. Let's do something first. Browser. So I already have my browser repository cloned, and I already have it packaged. And all those the instructions to do all that are in the README of that repository. So I already have a package which is in release. I'm going to start up the browser. Now, I don't have an account set up yet, and this leads me to something else I wanted to show you. safe-authenticator-cli. I highly recommend you cloning this and using it like so. So without this, where am I? Yeah, I'd have to create a new account through the GUI, and it will force me to make a highly secure credential here. And that becomes really tedious, especially if you want to delete your mock vault file, which I'll show you later. It'll reset everything. You have to create a new account, and it just becomes tedious. Or you might want to create multiple accounts. So let's go back to login. I already have the auth CLI here on my system. So what I'm going to do is, cargo run pretty, as in pretty printing, and then I'm going to pass the I flag, which is short for invite token, and that can be anything because we're interfacing with mock routing, right? Doesn't matter what the invite token is. I'm going to create my secret, which is just going to be Hunter. It just makes it really easy. Then account exists. My account exists. So that's because I already have a mock vault file. So I'm going to delete that now. I could have logged in with that, but that's fine. I'm showing you how this works. Okay, account was created successfully. Let's close that. Back to the browser, Hunter, and see, that's really easy. So fast to type in. Now when I log in, see, before I would have had to create a highly secure in this long credential, and I would have to keep that in my system clipboard to paste into the input field each time. Now I can just type in Hunter very easily. So that makes things easier. Back to the Electron app. So now npm start, and this is gonna we're gonna see an issue here. All right. So I've been thinking about how to. There's an important piece of knowledge here. How to educate share this piece of knowledge. Let me think about what to do here. Let me reinstall, and there's a message I want you to see. It's going to be an error message. Okay, good. So, weakref.o. Weak in API. Okay, so what was happening here was a module called node-gyp was running the rebuild command to rebuild certain modules so that they coincide with the version of Node.js that is being used by Electron. Now, I'm hesitant here because I don't want to say anything too confusing. Let's go back to safe-app Node.js. So safe-app Node.js, like I said, it downloads shared object libraries, which are generated, once again, I should have kept this up, by safe client libs. In order to use the shared object libraries, safe-app Node.js uses modules written in C++ to interface with those shared object libraries generated by safe client libs. Okay, so these modules in C++, they must be built for the correct version of Node. All right, and that is the purpose of this. You see this node-gyp. It's rebuilding those modules for the version of the version of Node.js that's being used by the current version of Electron that we're using, which in this case is Electron 1.8.8. Okay. Now I'm really sorry if that was confusing, but it is an important piece of information when you are when you inevitably come when you run into these types of errors. You know, like, I won't try to generate another example. Let's leave it at that. So right now, what I'm going to do is this has to do with a bad version of Electron. Okay, so let's change this to 2.0.8 and also, and also 2.0.8. Okay, so yeah, I'm gonna rely on Electron there, and then I want to rebuild targeting that version. Okay, so let's remove node modules, and I think that is it. I think that resolves it. Yeah, see that weak NAPI. think that was it. That's fine. So now let's start up the application. And that's it. We get our authentication, or our authorization request. I'm going to accept, and then you'll see that my Electron application popped up again because it received a response. So that's the next part. This is an important concept when you're building an Electron-based application. Let's see, what's the best way to... Let's go back to the code. Let me quit that. Let's go to the code here. So very quickly, overview of Electron. You have always one main process, and then you have multiple multiple renderer processes. So let's look at main.js. This instantiates the so for those who don't know, Electron is more or less a browser. It's based on Chromium. So it's the first thing you create is a browser window, and then everything else out from there. Okay, and then this controller.js represents a renderer process. There can be many renderer processes. So you'll see the first thing that happens when this application is executed is safe-network.send auth request. And let's see. Okay, so it's generating a URI, and then it is opening that URI on the system. Okay, now that URI makes its way to Authenticator, and how that happens is let's go over here to this should be in my .local share applications directory. This is where URI registry occurs. So there is a URI registered for everything. So file, HTTP. The reason that, like that, the reason that the system knows how to deal with those URIs is because there's a registry for that URI. And so the system comes to the registry and looks up how to deal with which application to execute to handle that URI. So in our case, we have this safe browser authenticator registry. So the system knows it's gonna. So we opened. Let's see, back over here. When we call open URI, this auth URI looks something like this, and it's like and there's going to be a lot of text here. Anyway, that's the safe auth URI. Okay, so the system is going to come to this registry and find that it needs to execute safe browser. Okay. And I'm not going to get into the implementation detail of the authenticator, but the safe browser forwards that URI to the authenticator, which is contained within the browser. Okay. So it processes that URI, and then that becomes, for the user, that becomes an authorization request, which was that pop-up that we saw, right? So when I pressed accept, now the authenticator is going to generate another URI. It's going to create a response, generate a URI, and then open that URI once more on the system, and that URI will look something like, oh, what is it? Is it safe? I think it's just safe. And then you have your BMV, whatever. It's going to be an encoded response. Okay, so the authenticator has called open URI on the system. So what happens next is the system executes an instance of our Electron application. Okay, and this, what's happening here, this piece of code covers this. So a second instance is created, and this is a Chromium implementation. This is an IPC implementation. The implementation sees that there's a second instance, and there should not be a second instance because we just want one instance. So it passes, it closes that second instance and passes that response to our single instance that we want open. So what we have here is this response auth URI, which makes its way back to our single instance. So then what we do is we send, and this occurs in the main process of our Electron application, okay? Then what we do is we send a message on the system URI response channel. And this is not a standard or a convention or anything. This is just a channel name that we made up, system URI response. And it's on that channel, it'll send the response, okay? So that's in the main process. Let's see, system URI response. Okay. Oops. Okay. Now, back in the renderer process, it's listening for events or messages on that channel, on the system URI response channel. Okay. So then we get the response and then we process it. Okay. Now let me know if that makes sense. Hopefully I'm not confusing anyone there about how URI registration works. This is our means of dealing with inter-process communication at the moment. We have other options we're exploring in the future. Let's see. I think that covers everything I really want you to know. The rest, as I said, is about filling in that skeleton, the safe-network.js skeleton code, and running some operations. And then I think many of our tutorials already go into detail about our network data types and all that. I don't think I need to go into that at the moment. Yeah, that's enough for now. Let me know if this is useful. If it's not at all, let me know how I can help you.